Okay, so today we've been asked to help a carpenter to cut an elliptical tabletop from a 900 centimeters by a 1.4 meter sheet of plywood using a string and two drawing pins to draw the largest possible ellipse. Determine what length of the string should be used and how far apart the pins should be placed. Right. So how we would go about it is obviously first drawing the actual box or the sheet of plywood that is given. So they're giving us a sheet of plywood and they say that the length is 0.4 meters and they're saying the breadth is 900 centimeters. But obviously when I get it to the same convention, so we're going to say it's 0.9 meters, right? So then from this, they're asking us to actually construct an elliptical tabletop that will fit into this, but as its maximum. So basically we want to get a ellipse that's going to fit right into this sheet of plywood completely like that. So we know if we construct an actual Cartesian plane on this, which will be, this will be our A value, right? Because our ellipse is elongated horizontally, so that will be our major axis, which will be our A and our A, and this would be our B and our B, right? So if we, it's a proven fact that if we have foci, so our foci is basically a point that will lie in here in the middle of our origin and our A value, and the same on this side because it's symmetrical, will be, so if we construct a line going to the circumference of the ellipse from the foci, the other foci, we can construct another line that will go to the same point, and therefore we can use this to draw our ellipse to a maximum. So basically what we're trying to find out is what this length has to be. So in order for us to determine that, right, we first have to determine what this point is, our foci points. So to determine your foci points, you have to say c squared is equal to a squared minus b squared. That is our foci. That's how we work our foci out. So our c squared is equal to our a value, which is half of this, because this whole length is 1.4. So to get our a value, we would say that divided by 2, which is 0.7 squared, minus b, which is this whole value divided by 2, because can you see it both attaches the circumferences, so it would be 0.45 squared. So that's c squared. C squared is equal to, so we would say the answer here, if you work it out on your calculator, you will get 0.2875, right? But can you see it's still squared, so we want to get c, just c. So if we say c squared, it would be that 0.2875, and then c will be equal to, if you work that out on your calculator, you would get 0.536 ... So the thing is, we don't want to round it off right now, because so that we can get the most accurate answer at the end of this of the whole ellipse. So right, we have that value there. So we want to get this value here. Can you see that these are at right angle triangles? So we can basically just split it up. So what we would do is split that up into right angle triangles, right? So because it's symmetrical, we can just work with the one side. So we're gonna work with this side here. So we know that this length is 0.536 ... We know that this length here is 0.45 because it's half of 0.9, right? So if we work out Pythagoras, theorem of Pythagoras says the length of the string, this is the length of the string would be equal to, so let's say length of the string squared is equal to, would be 0.536 ... squared plus 0.45. And why we do this is that the reason is for theorem of Pythagoras, So if we work this out, it would be RS is equal to, if you just do this whole thing and we take that squared away and square root that, we would get an answer of 0.7. So that length that we worked out there is 0.7. But can you notice that 0.7 is actually our A value, because our 0.14 is 2A. So if we want to get what A's value is, it's 1.4 meters divided by 2 gives us 0.7. So therefore we can conclude that not only is our length of the string equal to 0.7 times 2, which is equal to 1.4 meters, because we have to times by 2, because remember we're working symmetrically there. Not only that, but we can also say the length of the string required is equal to 2a. And that's our conclusion. So basically we would put the drawing pins on the foci, because it's the theorem that already states, that have been proven already, that the foci can be drawn, the two foci can be joined together on a point on the circumference, and it will be able to produce an elliptical tabletop. So in this case, the maximum lip, the maximum value that the string has to be is 2a, which is 1.4 meters, to produce a elliptical tabletop that can kind of be maximum within the paper.